Remember all the clouds of gases and dust during the galactic epoch? Yeah, well, they started to clump together because of a gravity by a nearby phenomenon. A clump attains more mass, therefore a stronger gravitational pull, attracting even more particles from the surrounding cloud. As more matters fall into the clump, its center grows denser and hotter. Over the course of a million years, the clump grows into a small, dense body called a protostar. It continues to draw in even more gas and grows even hotter. When the protostar becomes hot enough, its hydrogen atoms begin to fuse, producing helium and an outflow of energy in the process. We call this atomic reaction nuclear fusion. However, the outward push of its fusion energy is still weaker than the inward pull of gravity. At this point in the star's life, think of it like a struggling business that still costs more to operate than it makes. Material continues to flow into the protostar, providing increased mass and heat. Finally, after millions of years, some of these struggling stars reach the tipping point. If enough mass collapses into the protostar, a bipolar flow occurs. Two massive gas jets erupt from the protostar and blast the remaining gas and dust to clear away from its fiery surface. At this point, the young star stabilizes, and like a business that finally becomes lucrative, it reaches the point where its output exceeds its intake. The outward pressure from hydrogen fusion now counteracts gravity's inward pull. It is now a main sequence star. It will remain so until it burns through all its fuel. After burning for billions of years, a main sequence star will eventually exhaust its fuel. Supplies the majority of its hydrogen, it is converted into helium through nuclear fusion. The excess helium will then cause the star's temperature to increase. When this occurs, the star will expand to become a red giant. The red giant's core continues to collapse under the force of gravity. It will become dense enough to convert its remaining supply of helium into carbon. The fate of a star is entirely on the size of its core. Low-mass stars turns into the planetary nebulae. Towards the end of the red giant phase, at that point, the star becomes highly unstable and starts to pulsate. The outer layers are ejected by the resulting stellar winds. As the outer layers drift away from the star, the remaining core shines brightly and is very hot. The core is now a white dwarf star. The white dwarf star will cease to produce energy altogether and darken to become a black